Okay, well, so thank you, Jeff, for having me here, and it's a pleasure to be a sponsor and a speaker. I have a vast background in FRP and dual laminate, and appreciate the great presentations that we've learned these last 2 days. My industry now does have metal in it, so sorry about that. But the structural part of what I'm going to be talking about it is metal. The vessels are going to be designed to Section 8, ASME. But really what I want to focus on is the polymer liner, because that's the non-metallic part of the solution that I'm going to be talking about. And last year I presented on what is rotolining, and I just want to kind of dial into that a little bit more this year to talk about how you can have a successful project if you decide to go with rotational lining. And I call that return on investment. You're going to make an investment, you need to get performance out of that investment, which means service life and low operational costs. So the fact of the matter is there is no NM2, there is no RTP1 for rotolining. There is no ASTM standard. So you're going to trust us, just kind of like everybody trusted FRP 40 years ago before all the standards were written. So I want to tell you, as a potential engineer and procurement manager, what you need to know so you can communicate to a rotoliner what you want and you can get success so that the life expectancy is served. I'm going to just give a little bit of overview of what is rotational lining. It's just so abbreviated, what I did last year, just so that you understand, and in case people weren't here last year, they know what rotational lining is. And then I'm going to go into those steps that are going to provide you with the success and the life expectancy for that equipment. So rotational lining starts with a machine, and it's going to happen in a factory that does rotolining, never on site, never in the field. And two kinds of machines exist. There's a carousel machine and there's a rock and roll machine. Carousel machine kind of has a middle hub and everything rotates around it clockwise. So what you're looking at there is an arm with a fixture with two parts on it. The next step is it's going to go into a hot oven, and those parts are going to rotate in opposing axes so that the resin inside can move around and melt onto the internal surface and coat it, line it. And then after that station, it goes to another station where it cools. In this particular case, the space limit is going to be about 11-foot diameter by 11-foot tall, and the limitation is really going to be by weight, which is 7,000 pounds. So it'd be great for a vessel or multiple components that are fixed up to the arm there. The rock and roll machine is a completely different concept, and this is going to be a fixture that's inside of the machine that allows the equipment to rotate on its axis and then up and down into the ground 45 degrees. So that's how you're getting your movement for that resin to melt inside the component. The space window on that one is going to be 20-foot long by 5-foot diameter, up to 5,000 pounds. The steps in the process to provide rotational lined equipment are going to be first to burn the equipment out. It's always going to be metal. It can be fabricated fresh by the owner's chosen fabricator. It can be fabricated by somebody like us, or it could just be taken out of service because it had a failed coating or failed liner, and that is going to be burned out in this process, down completely decontaminated to the metal surface in a pyrolysis oven. After the burnout and decontamination of the part, then the grit blasting is the next step. This is very, very important because the bond of the resin onto that metal substrate is done mechanically. So the grit blasting provides a 3 to 5 mil surface profile. It's SSPC, SP5 white metal. And very, very important step, it must be done 100% through the whole inside of the part and onto the flange face where you want that resin to be lining. Another important point there is that all of the corners need to be ground into a radius. You can't have sharp 90-degree corners with rotational lining. It has to be smooth so that resin can flow around the corners. And in terms of root welds, they need to be ground flush. And there can't be anything that's going to be on the inside of this part is going to show through to the liner or possibly cause flaws. So it has to be nice and smooth on the inside. The next step is that we're going to fix it up onto the arm. So it's got to be securely fixtured. We do not want any vibration. We don't want it to fall down in the oven. So chains and whatever rigging equipment is necessary is used to put the part up onto the arm. Next is what we call a shot weight is determined, and that is going to be exactly the amount of resin by pounds that's going to be necessary to give the desired liner inside the part. So we do some geometry, we do some math, we figure out what that weight's going to be, and we pour it right into the part. All of the other openings to that piece of equipment are closed with metal covers. And once the resin is put inside, the part is started to rotate, put into the oven, and heated to the temperature that that resin is going to melt. It's got to be a resin that is melt processable. So part goes in the oven. We have a process time, 1 to 3 hours or so, comes out of the oven and is slowly cooled with heat or with air and water. So what happens then is it's a monolithic, stress-free, bonded seamless liner of resin inside a piece of metal equipment. All of the covers are taken off, and then we trim all the flange faces to true and flat. Was everybody already familiar with rotolining? Okay, so hopefully that was insightful. Typically with the fluoropolymer liner, we strive for a 3/16 thickness of liner inside the part. We can go up to a 1/4 inch thick. So you can see that that's pretty robust compared to like a sheet lining or a coating. So some of the just overall benefits to rotational lining, it's great for complex shapes. There are absolutely no plastic hand welds needed to get this monolithic bonded seamless liner inside of a metal part. It's stress-free because of the cooling process. And I like to think it really does maximize the return on investment. But I have to admit that if FRP is a suitable material, it's going to be less expensive. So if you're looking at temperatures and pressures that FRP lends itself, you're going to get a better return on investment by going that route. But there are going to be some considerations where I think you will want to gravitate toward rotational lining. So I stole this from hydraulic hose nomenclature, but this is an acronym stamped. If you are going to be wanting to come to a rotational liner, this is information that we're going to need. And this is going to maximize the potential for a successful project if we can get all this information. So the S is the size. A lot of times we work with customers early on so that we can divide the equipment so that it fits into our ovens. So if you have a column or maybe you have a piping system, by putting the flanges in the appropriate place, you can have some spool assemblies and so forth, but it's got to fit in our 2 machines, or else we're going to have to add flanges later, and that's just cumbersome. So doing the planning up front so that every piece is going to fit in the machine, that's going to be the best plan. Also, in terms of small diameter, 1 inch diameter nozzles and outlets and piping typically is going to clog with resin when it's flowing around inside and lining. So we want to try to stay at 1.5 inch diameter or greater. Temperature, it's always critical in process equipment. You know, what's the operating temperature? Also need to know any upset conditions, excursions, and we're going to use that information to determine what is the best lining material. Sometimes our customers know exactly what liner they want, and we'll do what they want. But if they come to us for advice, we're going to go to our resin suppliers, and we're going to look at their data and recommend based on their chemical testing data. Oh, and also thermal cycling. If there's severe and frequent thermal cycling, we need to know that information here at this stamped period. So what is the application? You know, is it a scrubber? Is it a process vessel? Is it a storage tank, a pump housing, a column? You know, we need to know what your application is, but mainly we need to know if there's something special about it. So let's say it's a scrubber and it's going to have some internals. Those have to fit. Those have to be supported. So we need to know all of the information about the small little details that are going to need to be designed, because everything inside this equipment is going to be lined. If you need a ledge or something to support off of, it's information we need to know. We're going to help you to properly design that so that it's functional. Oh, And like on a pump casing, a lot of times there are some critical tolerances there. It's totally fine to do machining after rotolining. And then what is the chemistry? Kind of a no-brainer. I think everybody knows you've got to report that when you decide on what the liner is going to be. So we need to know what are the chemicals, concentrations. Maybe there's going to be a cleaning chemical that we need to know what that is so that we're taking everything into consideration. Also, will it be erosive? Also an aspect to consider. Some resins are going to be better for erosion resistance than others. Pressure is not a big deal because it's the steel substrate is going to manage the pressure. The liner is just there as a corrosion barrier. So while in FRP, pressure is a big consideration for sure. Not so much with rotational lining because that liner, the pressure has no impact on it really. We have equipment that's been installed up to 1500 PSI, tested to 2200. It's all to do with the steel design. Oh, unless, of course, the metal fabrication is going to be done in-house, then we need to know all about the pressure because we'll be doing the metal fab. The ends, so with lined equipment, you cannot weld onto lined equipment without ruining the liner. So all of the ends need to be mechanical joints, like flanges. They can be lap joint, full face, raised face, but they must be mechanical bolted joints. And delivery. And I know if it was the hydraulic hoses stamped, then delivery doesn't mean what I'm meaning, but delivery in this sense is, when do you need it? So is there a certain outage period? Is it an emergency? What is the timing? Because if you have to wait until another type of material of construction has available capacity, it may miss your window. And with rotational lining, all it takes is a metal fabrication, components right off the shelf, made into metal fab, and then resin. And we always keep the resin in stock. So we could do it next week. We could do it in a month. We could get it turned around very, very quickly. So while I said that FRP is always going to be more cost effective, sometimes delivery governs the project and you need something right now. You've just opened up a piece of equipment and it's failed. You need to get it relined. So this is really one of the major advantages of rotational lining. And a consideration when you're talking about buying something. These are the resins that are available in melt processable forms that can be used for rotational lining. Like PTFE, for instance, it's not melt processable. It will not melt. So we can't rotoline with PTFE, but these are ones that are usable. So kind of at the bottom would be HDPE. Also, an additive can be put into the HDPE to make it antimicrobial attack or anti-biofouling. That's really more for offshore and applications near the ocean. HDPE by itself, it's good up to 180 degrees. It can actually be lined up to 1/2 inch thick, great for erosion, good for weak acids, brine, salt water. We do a lot of it in oil and gas applications. Up from there would be PVDF or Kynar. It is a resin that doesn't stick perfectly to the steel, so we have to use a primer with the Kynar. So it kind of bumps the price up a little bit, but it's got its applications. We get a lot of customers that have used Kynar as a coating, or for it's kind of what was the incumbent solution, and they just want Kynar because they know how long it's going to last or whatever reason. So we can do it. But the next resin up, the ETFE or Tefcel, readily available. We have 30 years of experience with it. It's great. It's impact resistant, erosion resistant, corrosion resistant, good up to 302 degrees F for most chemicals. It's going to be D-rated for chemicals like hydrofluoric acid, nitric acid, caustic, a little bit, but it's still got a really good temperature range. So that's our workhorse, is that Tefcel or ETFE for rotational lining. And then let's just say that, that none of those work, then PFA is the last choice. It's the most expensive. It is a 2-step process. And that resin by itself is good up to 500 degrees. Rotolining, we kind of have to look at the characteristics. Like if there's a lot of thermal cycling, we might have to take an exception. But we limit it to 24-inch diameter and 100 inches long. So it's good for smaller parts, pump casings, fittings, small manifolds, and small columns. The metal substrate can be carbon steel. It's probably going to need to be coated on the outside, but some customers actually just go straight to the stainless steel so they don't have to coat the outside. And we actually could line aluminum too, but it doesn't happen very often. So there are no standards for rotolining. There's nothing you can say, hey, I want you to adhere to this rotolining standard. So again, you're going to count on the quality control and the adherence to other specifications and standards that supplier is going to adhere to. And some of those things would be like the surface preparation. That would be the NACE SSPC SP5, white metal. We're going to conform to that. We're going to guarantee that it's been prepared to that. And that usually gives about a 3 to 5 mil surface profile, which is, again, really good for the mechanical bond. Another one would be the liner integrity. So this is a spark test, also a NACE standard, the SP0274. This is a standard that says you're going to apply a voltage based on the thickness of the liner and prove that it doesn't have any pinholes or flaws that would spark down to the metal. Very important step when it comes to quality control of rotolining. It's always in the data packet, and 100% spark testing has to take place to prove that it's got its integrity. The resin properties comes from the resin supplier. So they'll give a certificate of analysis that says, here's the melt flow index. Before they sent that resin out, it'll have a lot number. And again, everything else is traced. If you use resin, it's going to have a lot number and it's going to be traced. So it's no different for rotational lining. And the bond strength, there is a standard to test the bond strength of this resin to metal. It's the ASTM D3167. And it's like a floating roller peel adhesion test. So what we want is for it to fail cohesively. We want that adhesion to be so good that resin, it shows that it's sticking better than the tensile strength of the resin itself. And when we see those kind of results, that's where we can verify that you're going to get full vacuum rating. It's not going to collapse off of that metal substrate. And thickness measurements, there's really not an ASTM or NACE standard for this, but I like to mention this because traditionally it's been using ultrasonic testing to test the thickness of a thermoplastic liner. And now we've gone to an eddy current tester that's electronic it's very multi-purpose, but we can take readings across the whole entire component and send a report straight to the computer to show the various readings in the report and statistics on what that liner thickness is. That same tool can be used to measure the surface preparation, the 3 to 5 mils, and verify that in a report as well, just a different head on the component. ASTM F1545, that is a standard for line pipe. It's just not rotoline pipe. It's meant for loose line pipe, commodity loose line equipment. So it does not apply to rotolined or coated pipe, but it does have a section 6 with some qualification testing that's very valuable. And you may say to your chosen rotoliner, I want you to do that testing just because I want to have better confidence in your products. And it would be a high temperature, low temperature, steam, and vacuum test that can be performed. It's not a short-term test. Again, you're communicating to your rotoliner, and you want to tell them what you want. And this is also a very important part, material tracing. This is going to be delivered to you in the data book, and it's going to start with the materials coming in. It's going to provide all of the testing data and operator steps, and then you're going to get a data book with the full traceability of that equipment that's then coming to you in a data packet. And we've been speaking a lot about ITPs this week, and with rotolining, it's no different. You need to have an ITP. This needs to be communicated at the time that you're talking to your supplier. Make sure you're on the same page. A lot of the things that I've been mentioning are going to be on that ITP, like the surface profile before lining, that needs to be documented. The spark testing, that needs to be documented. The liner thickness mapping of both the flange faces as well as inside, and definitely a visual inspection. You need to make sure that there are no flaws in the liner. I mean, just like with FRP, the visual inspection is so critical. I mean, your eyes are how you're going to pick up on flaws more than anything. So the same goes with rotational lining. And at the time that the ITP is being generated, that's your chance to say, we want something more. Like, we do have a couple customers who have rotolining specs, and they have some extra tests that they want done, like a tap test is one of them. Some customers will say they want a hydro test after lining. It's very uncommon, but that may be something that is added as well. But I would recommend that you get a third-party inspector to the site, see the equipment just like you would any other material of construction. Just some photos of the various tests that take place. The spark test is up at the right, the liner thickness mapping down on the bottom right. And then this is one of the reports that's generated when we use this electronic gauge. If we're either measuring the surface profile or the liner thickness mapping, we get a nice report that shows all of the readings and graphs them, and we're able to verify that we're within the limits that we intended. The next part where something could go wrong is after it leaves our plant. And the transportation and handling is very important. A lot of this is kind of boilerplate for any kind of equipment, to be totally honest. But when it comes to rotational lining, you just have to protect the liner. So you're going to see that, when we ship, we always put them over horizontal just for safety. And they're going to be on cradles as much as possible with carpet to protect the painting. All of the flanges are covered with either plywood or plastic, and that's so that nobody damages that liner in transit. It's always better to go with a dedicated truck. I'm sure that's probably true with FRP and dual laminate equipment as well, but you don't want to handle this 2 and 3 times on the way to the destination. And also that the uninstalled components sometimes can be stored inside the vessel, so be sure to look for them there. In terms of unloading, just be really careful with the forklift tines not to damage the plastic. In fact, keep all the covers on or put them right back on if you want to look inside as much as possible. What we hear the most is, oh my gosh, we dropped the part, or somebody nicked the face of the flange when we were installing it. And that's never a good situation. But if you keep the covers on as much as possible, that's going to be prevent it. But with that said, as long as the damage doesn't go down to the metal, then it can be repaired. So you can get somebody who's a certified plastic welder, they can come and do a weld repair and then grind it back down. That's doable. If the damage goes down to the metal, then it's going to have to be relined. So that's not good news. So just be very careful about damage on the flange spaces. Of course, the first line here is very important, to inspect the equipment when you get it. I just can't emphasize that enough. Just look it over. Even if you're not going to install it, take a look at it, make sure it's what you expected. Obviously, you did have third-party inspections, so you should know a good bit. This is just really a safety list that would be applicable to any new asset that you're installing about safety. I'm going to skip along here. And then bolting. We've been hearing a lot about bolting lined and FRP equipment. The same kind of guidelines are going to take place for rotolined equipment. You want to have one bolt thread visible past the nut when you install the fasteners. If the leakage occurs, adjust the bolts rather than over tightening. There are maximum torque levels for the liners that we provide, which we publish in our installation manual. But generally speaking, you're going to follow the gasket manufacturer's guidelines for torquing. I think I've already heard this 2 or 3 times, but you're going to want to retorque after 24 hours, conduct the hydro test after the torque and the retorque, and retorque annually, because there could be some loosening up of the bolting system, especially if there's temperature fluctuations. So what I really want to emphasize on this slide is that it's very important to communicate to your plant never to weld on rotoline steel equipment. It's going to damage the liner on the inside. In fact, you really don't want to have it installed where there could be excessive heat coming adjacent to it. I always recommend that whenever possible that you can get into your rotolined equipment to take a look at it, do so. I mean, try to lay eyes on it. It is possible, if you can get in there and clean it out, that you could do a spark test. You can do a tap test on the outside to hear for delaminations. So there are ways to do inspections. If it's properly specified and the right materials are used, you're not going to have problems. But if you can lay eyes, you do want to do inspection whenever possible, like within a year, maybe within the 3 to 5 years after that. We have equipment that's been in service for 20 years and more. So just in a nutshell, This is kind of a summary of what I think are the most important things. It's really important to communicate everything right up front. And this is especially going to be any of the special attributes about your project. What is the application of your project, of your product? Is there anything going to be inside of it that needs to have a special clearance dimensionally? Who's going to fabricate the metal? Or is it something you're planning on taking out of service and having lined? And is there vacuum? If there are vacuum conditions, we need to know that because some resins are going to stick better than others. Is there anything near it that's going to apply some extra heat or chemistry to this system that we need to know about? Is it erosive? It is an erosive service. So these are all really important points early on that we need to know about so we can give you the best solution. Of course, the material selection, it's critical. You don't want PFA if you don't need it. Go with something that's going to adhere well, like an ETFE, if it fits for your chemistry. Even if you could go with HTPE, that's going to be even less expensive. So, don't overdo it and get the right resin for your application. And then, of course, the design, you need to make sure that early on, we make it so that it fits in our machines. And in fact, we have a customer right now who's got a column. The pieces were 20 foot long. It was all going to be great. We were going to be able to maximize this particular machine, but they wanted to design it for 300 PSI. So they used Schedule 60 material, which is like 1 inch thick. So the pieces were too heavy in 20 foot lengths to go on that machine. So these were just some really important details that we needed to learn about so that we could break it up into pieces that weren't too heavy. So it's really important conversations early on. Can't emphasize enough about the ITP, doing source inspection, get involved with the supplier. I mean, this is not going to be an inexpensive piece of equipment. It's for critical service. So treat it just like you would an FRP or dual laminate asset. And of course, careful handling. Never weld on the outside. Keep the covers on as much as possible. If something does happen, contact the manufacturer and see what can be done. Yeah, the bolting techniques. We have an installation manual. Follow it. Whoever's going to be your supplier, they're going to have that information available. Again, retorque. Follow that procedure, and try to do inspections when you have access to the equipment.